Hello and welcome to this video about Pandas for data handling. We are excited to have you here, and in this video we are going to talk about Pandas operations and techniques. In this video we will talk about concatenating Pandas data frames. The Pandas concat function is one way to add two or more data frames together into one data frame. And we can add the data frames together both vertically and horizontally with Pandas concat function. The concat function is extremely useful for common situations when similar data frames or data frames with similar feature and index structures need to be added together. And now we're going to talk more specifically about the Pandas concat function. And the concat function can add data frames together vertically and horizontally. Vertical concatenations are the default mode, and the concat function accepts two or more data frames as arguments, or even collections of data frames as its argument. So we can, for example, feed it a list with data frames, which may be a very useful way to add a large number of data frames together. And the concat function provides us with several useful tricks. The concat function can add new keys or index columns with index labels for concatenated data frames, plus give the new indexes unique names. And the concat function can add data frames horizontally, an addition which functions on a key versus key basis and may create missing values when keys are missing in one or maybe all of the concatenated data frames. Adding data frames horizontally creates more columns, and the concat function can handle these new columns with a similar scheme as when adding data frames vertically. The concat function uses outer join methods as a default, but can also use other types of joins, for example, inner joins. Outer joins means that all rows are added together regardless of the key structure in the different data frames, whereas inner joins means that only rows which have the same key in both data frames are added together. And now it is time to type some code, so start up your code editors. Alright, having started our Jupyter Labs notebooks, we are now going to type some concat function code. And on your screen you can see some code which you can download and cut and paste from the file attached to this video lecture. And here we have 4 pre-constructed data frames which we will work with in this video. And these 4 data frames are standard, and they are simple to use and to understand. So the first data frame is our basic car sales data frame, which we have used in many earlier videos in this video course. And the second data frame has 2 more sales places in a data frame, which is structured exactly as our basic data frame. And in practice, these 2 new sales places to the car sales data frame simply adds 2 more sales places to the basic data frame. And the third data frame will add more car brands to our data frame from the side, horizontally. And this data frame may also be used to display the concat function's handling of keys and missing values, as well as indexing. For example, if the index contains duplicates, this function may throw an error. And the fourth data frame we can use to display the concat function's handling of some duplicates and some other items. So, all right, let's begin. And we will begin by importing Pandas as PD. We type import Pandas as PD. And we will run this code. And as you can see, we have a lot of print instructions. So we will print these preloaded data frames to check that they are loaded properly. So let's run this code. And here we can see that we have sales places in this data frame, and it has been loaded properly. And similarly, we can see that the second data frame simply continues the first data frame. And we can look at the third data frame, and here we can see that it has some unusual things in the index labels. For example, we start with sales place 1, the second is 9, the third is 3. And this means that label 2, 4, and 5 are missing, as well as label 8. And we have an additional label 9 added to this data frame. And this data frame will be used to cause some mismatches in the index labels when we concatenate data frames. And the fourth data frame contains sales place 1 and 2 again. So here we can see that we have true duplicates in one data frame. And we will use this data frame simply to inject some duplicates in the process. All right, now we'll begin to type some code, and we will begin by simply adding two data frames with equal structure using the concat function. We can type car sales 5 equals PD concat, and we can use the car sales data frame and the car sales 2. And we can print car sales 5. So let's run this code. And here we can see that we have simply added car sales 2 vertically to the car sales data frame. Now we have extended this data frame with two sales places or two rows. And these rows are perfectly named in the index label tradition which we have. But as you remember, the computer sees these labels as strings, which are totally unrelated to each other numerically. Whereas when you see this in your mind, you might see a relation which is 1, 2, 3, 4, 5, 6, 7, 8. But the computer doesn't see this. He sees only the string labels. And unless you create a translation table for the computer, it cannot see these numerical relations with numbers. And this is important when it comes to index labels and the concat function, that index labels are strings. And we can continue and we can add two data frames horizontally using the concat function. And let's use an uneven structure to show the concat functions handling of indexes, missing values. We type car sales 6 equals ed concat, and we use car sales 5 and we use car sales 3. And we set the axis to 1 and axis equals 1 will instruct our computer to execute this concatenation horizontally instead of vertically. We print car sales 6. So let's run this code. And here we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, and 9 in our index. What has happened is that the new 9th index labels has been added at the bottom. And as I said earlier, this is just a coincidence. So this data frame has not been sorted, but this has just been added as a new string label not equal to the earlier string labels. So it has been placed at the bottom. And here we can see that this 9th index label does not exist in the first data frame, and therefore all values from the first data frame has been entered as missing values. And similarly, all missing index labels in the second data frame has had their column values entered as missing values in our new combined data frame. So here we have an excellent example on how the concat function handles indexes and missing values when the structures are compatible with each other. And if you want to check and do a little exercise, it could be interesting to create a duplicate, for example, in the first or the second data frame and see what happens. Because when you add data frames with this function and there are duplicates, for example, in the first car sales 5 data frame, then it will throw an error. And this can be a bit insidious when you work with this type of data. But you know how to handle duplicates, and in my opinion, it's just an issue of time and development, because this concat function is developing very quickly, and it has competed against many other functions and won. So many other functions has been replaced with the concat function, and the older functions has been deprecated. So this concat function is very likely to live on, and it will develop. And this is one of the issues that will be fixed in future versions of the concat functions. In the future, perhaps you will have another argument to add, which will handle this situation with duplicates. For example, that every found duplicate on one of the data frames gets a value from the one or the more duplicates in the other data frame. And there are several ways to solve this, or to throw a warning, or put up some other type of instruction to resolve this. All right, we can type, as you can see, using the concat function on data frames with unequal indexes and structure results in missing values, as the concat function uses outer joins as default. Let's try a inner join instead. And we can say that an inner join drops all rows which don't have an corresponding index label in the concatenated data frames. So let's type car sales 7 equals pd concat, and we can use car sales 5, car sales 3, axis equals 1, and join equals inner. Let's print car sales 7. And let's run this code. And here we can see that in our new data frame, which used an inner join and otherwise the same method as the last time, all index labels which were not present in both data frames were dropped. So for example, label 9 did not make it because it was missing in the first data frame. And label 8 was dropped together with label 5, 4, and 2 because they were not present in the second data frame. So this is the inner join and the outer join with the concat function. And in following videos, we will talk about the join function and look more carefully at what a join method is on a data frame. So we will look more carefully and more deeper and more detailed at the join functions. And now we just demonstrate the functionality when the join instruction is used with the concat function. So let's take a look at duplicate index labels and some of the effects when using the concat function. We type car sales 8 equals PD concat, and we use car sales and car sales 4. And we print car sales 8. So let's run this code. And here we can see that the concat function is perfectly able to add duplicate index labels to a data frame. No crashes, no problem, as long as the structure is equal. But we also know from our earlier speech, and if you make this exercise, which I talked about earlier, that index labels, when added horizontally, will throw an errors if there are duplicates in the data frame. And the function that creates this different handling when you're talking about duplicates is because the treatment vertically is numerical in nature and uses the invisible numbers related to the data frame, whereas when you concatenate horizontally, you need these index labels to put the right values on the right row. And therefore the duplicates currently throws an error. But as I said earlier, this will develop and they will find a way to handle this little issue. And until it is resolved, you simply have to handle the duplicates in the index labels if you want to use the concat function horizontally. We can type that we can conclude that the concat function may add duplicate index labels and also column names. And we do like this with dots to state that this is not all the necessary facts, which you may need to study deeper, for example, in the exercise, which I talked about. Finally, we can make a brief check on two-level indexing with keys and names. We can type car sales 9 equals PD concat car sales and car sales 4. And we type keys equals car sales car sales 4, names, data frame, sales place, and we print car sales 9. And this code will create a 2-level index and use the keys and the names which we typed. So the first level will be the car sales and the car sales 4 used as keys, and this index will be named data frame. And the second level index is already named, but will be specifically named as sales place. So let's run this code. And here we can see that this index, sales place, has been named 1, 2, 3, 4, 5, 1, 2, and we also have a index of data frames. So here we can see that car sales is this data frame, and here we have car sales 4, which is the second data frame. And this, we could say 2-level or multi-level indexing is useful in many situations because you can point at a particular data source using this instruction. But it also creates a lot of complexity which may require extra code typing and all such things. There's a saying that the simpler you keep something, the more effective and efficient your work will be. And advanced indexes is a great way to explain why simplicity often beats complexity. So we can type in car sales 9, we have a 2-level index and can select using both sales place index labels and the data frame keys, or you could say index labels. All right, in this video you have learned a lot about the fundamentally useful Pandas concat function. And we look forward to see you in the next video.